Let's compare discrete random variable and continuous random variable. For discrete random variable x, so I let x be a discrete random variable. That means x has a countable number of outcomes. Versus for continuous random variable, x has countless number of values in a line interval. One of the ways to distinguish the difference is for discrete. So for the word discrete, I usually just draw a few dots on a piece of paper, and then I ask you, how many dots do you see? How do you answer this question? You use your finger, right? You count 1, 2, 3, 4, 5, 6, 7. I see 7 dots. So the number of dots is countable. Versus what happens if I just draw a line? How many dots do you see in here? Infinitely many, because this line contains infinitely many of dots. I'm going to say the number of dots is not countable. I am not able to use my finger to count the number of dots, but it's measurable. So I can use a ruler to measure the length of this line. I cannot count, but I can measure. So for discrete is countable. Continuous is not countable, but measurable. So for discrete, you have to say 7 dots, right? How many dots do you see? 7. For continuous, if you do a measurement, then you have to give me a number followed by a unit. So let's say 5. 5 what? 5 inches or 6 centimeters, something like that. Measurable, it will be a number followed by a unit. Countable, you just say 7 dots or 7. Okay, so let's do another example. For this one, when you reach to a continuous random variable, because the next lesson I would introduce continuous random variable. So for the discrete, I am going to use an example called binomial distribution. Binomial distribution. Okay, so let's say we have a random variable x that follows binomial distribution with n independent trials, and the success rate is p. So what is that means? Let's say I am testing 5 products. 5 products, okay? They are all independent. You have 5 products in front of you, and then the defective rate is, let's say, 5%, and then the p is 0.05, and then the x is the number of defective product. Is that countable? Yes, because x can be 0. You test all 5 of them, you have no defective product. X can be 1, x can be 2, x can be 3, x can be 4, and then x can be 5. And then you have to use a binomial formula. So you have the independent trial n is equals to 5, the p is equals to 5%, and then when x is equals to 0, what is that probability? When x is equals to 1, so out of 5 products, the success rate is 5%, or the defective rate is 5%. What is the probability that 0 of them is defective, 1 of them is defective, 2 of them is defective, and then you keep going, and then that will give you 6 probabilities. And then for the result, you need to use a table to summarize them. Okay, so I have n, p, and then x, and then I'm going to say each x has its probability. Okay, and then you can make a table like that. You have x, and then this is the probability of success, and then x can be equals to 0, 1, 2, 3, 4, and 5. And then each x has its own probability, and then the sum of all the probabilities is equals to 1. So I just use a table to describe or summarize the probability distribution of this random variable x that follows binomial distribution. But what about continuous random variable? Okay, continuous random variable, I can do binomial distribution. I am going to say let x, so that is another x, equals to the mph. mph represents the mile per hour that vehicles crossing an intersection. Crossing an intersection. and then let's say the speed is between 7 miles per hour and 24 miles per hour. Okay, and then we have a line interval, right? We are no longer having dots. So this is the minimum is 7 miles per hour, and then the maximum is 24 miles per hour, and then there are infinitely many dots, right? Between 7 and 24. You can say there are infinitely many numbers between 7 and 24. You can say 7, 8, 9, 10, 11, 12, 13, 14. But what if we count the decimals? Because for miles per hour, I can have 7.11, 7.22, 7.55555, right? I can use decimals for miles per hour. But if you look to the left-hand side, how about the number of defective products? Can I say 4.1 products are defective? No, that doesn't make any sense. You cannot have any numbers between 4 and 5, either 4 or 5, not 4.1, not 4.2. But for the miles per hour, I can have 8.55, 9.002. I can have numbers like that. And then this random variable, x, is not countable. So since x is not countable, how do we describe that? Can we still use a table? No, we cannot. We have to use a graph. Not a table. Certainly not a table. A table is not going to work. Not a table. We have to use a graph or a function to describe the probability or to represent the probability distribution. Probability, I'll just write PROB, distribution of x. So basically the difference is countable. You need to provide a table to describe the probability distribution. That is for discrete. Not countable, then that will be for continuous. Then you have to state the minimum, the maximum, and then you have an interval x between the minimum and the maximum. And then regarding the probability distribution, you need to either provide a graph or a function to describe the probability distribution of this random variable x. All right, so that is the difference. That is the end of this video. I will see you all in the next one.